Howdy, I'm Brian. Today I'm going to show you how to integrate virtual ECUs into VeriStand, which is NI's application software for hardware-in-the-loop, or HIL, and embedded software test. A virtual ECU contains not only the application logic for an ECU, but also the actual production code, and can be run without the ECU hardware. This can be extremely valuable for system integration type tests where you might not have the hardware immediately available while you have the software still in development or already pretty validated. With the new Virtual Validation Development Suite, you can integrate virtual ECUs directly into your HIL system, allowing you to interface with a mix of real and virtualized controllers. Let's take a look at an example within VeriStand today. So here I have a VeriStand screen. I'm first going to talk through what this example is, and it's a pretty simplified one where we have three simple ECUs, a light switch ECU, which is really just a simple sensor as an off and on at an auto state. We have a headlight ECU, which is more or less a simple actuator that takes in whether the lights should be on or off, and then a light control ECU, which will interpret both the off, on, and auto states from the light switch ECU, as well as an external sensor that can simulate the outdoor light intensity as a percentage. When we hit 70% in the auto state, we'd expect that signal to be off then for our lights. If it's light outside, we don't want our lights on. When it's dark out in an auto state, we want the lights to be on. In VeriStand, what that's actually going to look like in this case is we're going to pretend this headlight ECU is a mock DUT that I have created with a LabVIEW VI. The other two ECUs are going to be brought in as virtual ECUs. These have been pre-generated from Synopsys Silver software. So these are already assets that I can leverage easily and integrate into VeriStand. And all three of these are going to be communicating over the CAN cluster. The light switch and light control ECU are communicating via virtual bus, while they're also actually outputting physical bus data onto the CAN cluster that can communicate with the headlight ECU. Let's jump over into our mapping diagram to configure the system definition. I have two user channels pre-populated here. Let's see what we can do to add a virtual ECU and configure it. Similar to simulation models, I can go over into our software elements palette, drop a virtual ECU. I have a couple of those assets from Synopsys Silver software. I'm going to drop in my light control FMU first. You can see it has similar properties that I can set in the configuration pane in the right rail as simulation models, as well as imports and outports. I'm going to drop a second virtual ECU. This one will be the light switch. Similar scenario where I have the same properties that I can configure, as well as some other imports and outports that are available. The last thing I need to do is actually configure an ECU network cluster, which tells us how those virtual ECUs are communicating between each other, as well as how this bus data is output on the line itself. Let's go to a ECU network cluster I have pre-configured. These can also be created from scratch. The information we need is the cluster name itself. In this case, that comes from Synopsys Silver software when we output this virtual ECU. The time step, the protocol. VeriStand supports CAN, LIN, and Ethernet at the moment. The I/O mode, so we can have CAN standard, CAN FD, CAN FD BRS. The baud rate, the actual physical XNet interface. This is CAN 3 on our PXI system. The toolchain, in this case Synopsys Silver, and the virtual ECUs that are going to be communicating on this ECU network cluster. In this case, that's both of the virtual ECUs we've dropped. At this point, I'm going to deploy, which will send all these files to our RT target, and then VeriStand can start executing them. And now we can see we have deployed and we are connected to the system. I'm going to go back to my screen here. I've pre-populated a few controls here, one for a light switch, one to control the light intensity. At the same time, I'm going to move over and be able to show the LabVIEW VI, which is kind of representing our mock DUT. It just has some simple headlights here. So with VeriStand, now maybe the first thing we want to see here is if I turn my light switch on, do I see the headlights actually pop up? It's on. I can see my headlights have triggered on. If I go into the auto state, what should we expect to see here? Our light intensity is really low. It's dark outside. We expect the headlights to be on. Let's bump those up so it's a brighter, sunnier day. As we can see pretty quickly, the headlights turn off. We don't want our headlights to be on a perfectly sunny day. I can drop those back down. Headlights turn on. Lastly, I can go back and just test what happens if I turn my headlight switch off and my headlights turn off. So that was a simple demo here today showcasing how we can integrate virtual ECUs for system integration tests inside of VeriStand.